Okay, this video is over Chapter 8 of your textbook, which is titled Intrusion Detection Systems. So in this chapter, we will talk about intrusion detection systems. Even though your book doesn't talk about it, we will talk about intrusion protection systems briefly. We'll talk about common IDSs. We'll talk about the architecture that is used in IDSs, and we will talk about alerting from intrusion detection systems. So first off, IDS, which I think I've mentioned before, stands for Intrusion Detection System, of course, and it is a cybersecurity tool that monitors network traffic or system activities looking for malicious behavior, security policy violations, or unauthorized access attempts. The first widely recognized IDS was named IDES, which stood for Intrusion Detection Expert System, and it was developed in the mid-1980s. So back in the 80s, expert system was a term that was used a lot, and at the time it was kind of what AI is to modern day as far as solving problems. There were some lesser known ones that were created back as early as 1980, but like it said above, IDES was the first widely used one. There are different types of styles. That is, how does the IDS perform its work? The first one we'll talk about is called signature based. So basically, someone identifies a pattern related to a certain attack, viruses, or other exploit, and that pattern that you see within the malicious behavior is referred to as the signature. This is how a lot of antivirus programs work. Heuristic detection style is searching for patterns or activity that are considered abnormal. And these days we have AI based, which uses machine learning and behavior analysis to try to identify threats. There are host-based IDSs, which mainly focus on activities on the host. Some well-known host-based IDSs are OSSEC, which we'll talk about a little bit more in detail here in a moment, WASH, Tripwire, which we'll talk about in a moment, and Microsoft Defender for Endpoint. And there are many, many other IDSs that are host-based. That is different than network-based IDSs, which monitor network traffic trying to detect suspicious activity. Some well-known network-based IDSs are Snort, which we'll talk about in detail and may actually visit later in the semester again, Suricata, Zeek, which used to be named Bro, and then Cisco has something it calls Cisco Secure IDS, and there are many, many other network-based IDSs as well. So a very common one is Snort, and it got its name because a snort is the sound a pig makes when sniffing. And using things like Wireshark is referred to as sniffing the network. You're looking at packets trying to find something. These days, Snort is maintained by Cisco. However, it is open source, which means it's free, and source code is distributed. But there are add-ons that you can get that cost money, or you can pay for support. So if you use Snort, for example, and you need help configuring it or help modifying it, you can buy a support contract, which will cost you money. The source code that I mentioned is downloadable from snort.org, and Snort currently runs on Unix and Linux machines and Windows machines. Now, the architecture of Snort is, first, it has preprocessors, and it examines the network traffic before it reaches the rule engine, which is the heart of Snort. And you can do things like, say, I want all the network traffic, but I don't care about ICMP conversations. So the preprocessor would remove those from whatever network traffic it passed on to the rule engine. There are configuration files that control how Snort behaves, what traffic is inspected, and what action to take when a threat is detected. And then, as I alluded to before, we have the rules, which are the heart of Snort. And they are the detection logic, trying to find abnormalities or malicious packets. Suricata and Sagan are similar to Snort in their behavior. They can use the same rules that Snort uses. They can generate the same output that Snort generates. When Suricata was developed, it was multi-threaded, and Snort was not. Snort is now multi-threaded, and if you're not familiar with that term, it's kind of hard to explain, but I like to explain it as you have different pieces of a program running simultaneously. So the actual process has multiple threads or multiple computing following either a duplicate of the code or possibly even a different portion of the code somewhere else in the program. The other thing too that is a little different is the config files use YAML. That makes it easier to deal with because YAML is pretty easy to understand and it is more efficient than processing the config file the native way in Snort. Another one is Bro. Like I mentioned earlier, it's now referred to as Zeek. It came out around 1999, and it was written by Vern Paxson, who at the time worked for Lawrence Berkeley National Laboratory, and he was also affiliated with AT&T Center of Internet Research. And the goal at the time was to support high-speed fiber networking. And it is also event-driven. So you explain an event that you want to investigate or trigger on, and when that happens, functions are called to deal with that event. So here is an example event. So basically what this is saying is if we see an HTTP reply and the status code is 0 and we have that string, that regular expression, which starts with HTTP regardless of the case, and it has to be at the beginning of the string, that's what the caret is, then I want to print out a message that says I have a local server that is acting as an open proxy. Which is something that might be legitimate or it might be suspicious in nature. So it prints out a message so that somebody can investigate that and see if it is indeed a problem. The next one we're going to talk about, which has been around pretty much for a very long time, is Tripwire. It was developed in the 1990s and open sourced in the year 2000. It is a host-based IDS, and what it does is for every single file on a system, it generates a hash. So a digital signature that is tied to the contents of a file. So you can think of it as a checksum. But it's a hash that is created by the contents of the file. And then what you do is you watch for files whose hash value changes over time and alert on that. If you do a software update, that might do some things and change files, but it could also be hacker activity. So that's how Tripwire works. Another one I mentioned earlier was OSSEC. It was released in 2004. It is another host-based IDS. It does what Tripwire does, but in addition, it will also check for rootkits. It will do log monitoring, and it will do process monitoring. So trying to see if there are suspicious processes running. Now, as far as the architecture, there can be different architectures, but a number of modern IDSs use the concept of placing sensors around your network to gather information and send it back to a central device or system that would be referred to as a collector, so that you have information from a large portion or potentially all of your network that you can use in an investigation. Another topic the textbook talks about is alerting from an IDS system, and this would be alert messages that are generated that need to be seen or reviewed by a person. And there are many levels of severity, and therefore different ways to alert. You might even use a combination of these, especially if it's something really urgent. But a lot of IDSs have a dashboard that show information, and you might have a collection of network connections, and if something suspicious happens, you might turn that connection red, for example, to get an attention of somebody in your network operations center, your security operations center, or data center. You can write these to a file. This is something that happens a lot in conjunction with other ways to notify people. This way it can be used as evidence, but it would require somebody to go review that file periodically, looking for abnormal behavior. We talked about syslog before. One of the components of syslog is syslog forwarding, where you basically forward the files that would normally be in your syslog files to a central syslog server, which is basically a collector. It would collect that. You can send out email notifications to people when you want them to check something, and maybe a little more timely, you can send SMS notifications. And again, it's important to know that it can be any combination of these. So that is discussion of IDSs, and this completes the lecture for this chapter.